Hi students, hope you are all doing well. Welcome to lecture 2 of quadratic expressions. Hope you have reviewed the first lecture. Let us review some of the concepts that we have studied in the last lecture. The first point is the roots of a quadratic equation ax square plus bx plus c is equal to 0 or minus b plus or minus under root b square minus 2a. This formula we have used to find out the roots of a given quadratic equation. The second point is the discriminant of a quadratic expression ax square plus bx plus c is b square minus 4ac and it is denoted by the symbol delta. This we have seen already. The next point is the nature of the roots. We have studied a result based on the discriminant. That is, by looking at the discriminant of a quadratic equation, ax square plus bx plus c will be able to tell the nature of the roots. This is what they are mentioning. When delta is equal to 0, the roots are real and equal. When the delta is greater than 0, the roots are real and distinct. And when delta is less than 0, then the roots are complex. And the next point that we have studied is let alpha comma beta are the roots of the quadratic equation ax square plus bx plus c. Then we have this relation alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. This is actually the relation between the roots of the quadratic equation and that of coefficients of the equation. If alpha comma beta are the roots of ax square plus bx plus c, then we have seen this relation. We can factorize it actually. That is, ax square plus bx plus c can be expressed as a into x minus alpha into x minus beta. Now we are going to use these concepts in solving some of the problems. Now here is a problem actually. If alpha comma beta are the roots of the equation ax square plus bx plus c, then find the values of 1 by alpha square plus 1 by beta square. Here is the question. Now let us answer this question. Here is the solution. Let us solve this question. Now we are given that alpha comma beta are the roots of the equation ax square plus bx plus c. Just now we have seen the relation between the roots of the equation and that of coefficients of the quadratic equation. That is, alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. Now using these two relations, we have to find out this quantity. Now let us write the given quantity, that is 1 by alpha square plus 1 by beta square in the known terms. This can be rewritten as alpha square plus beta square divided by alpha square into beta square. Now let me rewrite this. This is equal to alpha plus beta whole square minus 2 alpha beta divided by alpha beta whole square. Now we have written this quantity in terms of these two quantities. These two quantities are known to us. Alpha plus beta is known to us and alpha beta is also known to us. Now let us substitute this alpha plus beta in the above expression, that is minus b by a whole square minus 2 into alpha beta is c by a divided by c by a whole square. Now, if I rewrite this, then we have b square minus 2ac whole divided by a square divided by c square by a square. Now the final answer is going to be b square minus 2ac divided by c square. So the final answer is 1 by alpha square plus 1 by beta square is equal to b square minus 2ac divided by c square. Now let us solve the next question. Now we have to rewrite this quantity alpha by beta minus beta by alpha whole square. Now let us rewrite this quantity. This can be written as alpha square minus beta square divided by alpha beta whole square. Now that can be written as alpha minus beta whole square into alpha plus beta whole square divided by alpha beta whole square. Now that can be rewritten as, now alpha minus beta, we don't know the value actually. Now we have to rewrite that quantity. I am writing alpha plus beta whole square as it is divided by alpha beta whole square as it is. I am going to change this quantity alpha minus beta whole square. Now that is alpha plus beta whole square minus 4 into alpha beta. Now this is going to be alpha plus beta whole square, that is minus b by a whole square divided by c by a whole square into alpha plus beta is minus b by a whole square minus 4 into c by a. So that is equal to b square by c square into b square minus 4ac divided by a square. Okay, so the final answer is going to be b square into b square minus 4ac divided by c square into a square. So this quantity alpha by beta minus beta by alpha whole square, this quantity is going to be, I'm putting in the given box, right? Okay, now these two questions are answered. Before getting into further problems, let me discuss a theorem here. The statement of the theorem goes like this. The roots of a quadratic equation a1x square plus b1x plus c1 is equal to 0 and a2x square plus b2x plus c2 is equal to 0 are identical if and only if the coefficients a1, b1, c1 and a2, b2, c2 must be proportional. And in this case, this must be a1 into x square plus b1 into x plus c1 is equal to a1 by a2 into a2 x square plus b2 x plus c2. Okay, let me discuss the proof of this. The proof is simple. Okay, so this is an if and only if condition. First we will prove one way. Let us assume that the, let me call this as equation 1 and let me call this as equation 2. Okay, assume that the roots of equation 1 and equation 2 are identical. Identical means both are same. Okay, so this implies alpha comma beta are the roots of, we let alpha comma beta are the roots of both equation 1 and 2. Okay, so this implies if alpha comma beta are the roots of equation 1, then we have minus b1 by a1 and alpha plus beta. If alpha comma beta are the roots of equation 2, then I'll get minus b2 by a2. So from these two we get alpha plus beta is equal to minus b1 by a1 is equal to minus b2 by a2, implies b1 by a1 is equal to b2 by a2. Now similarly, if alpha comma beta are the roots of equation 1, then the product of the roots is c1 by a1. Similarly, if alpha comma beta are the roots of equation 2, it is c2 by a2. Product of the roots will be c2 by a2. This implies alpha beta is equal to c1 by a1 is equal to c2 by a2, implies c1 by a1 is equal to c2 by a2. Now what is that we have to find out? We have to we have to show that the coefficients are proportional. Okay, now let me write my equation a1 x square plus b1 into x plus c1 is equal to, I am taking common a1 here, plus this becomes x square plus b1 by a1 into x plus c1 by a1. Now let me call this as equation 1. Sorry, let me call this as equation 3. Let me call this as equation 4. Then if I substitute equation 3 here, equation 3, then I get b2 by a2 into x plus c2 by a2. So if I take the LCM, this becomes a2 into x square plus b2 into x plus c2 divided by a2. So this implies a1 by a2 into a2 into x square plus b2 into x plus c2. So here is the result. That means we have proved in this case the coefficients are proportional. If the roots are identical, then the coefficients are proportional. Now, the proof is continued here. Proof continues here. Okay. Now, what is that we have to prove here is if the two quadratic equations are related like this, that means the coefficients are proportional. What I have to prove is the roots of these two quadratic equations are identical or same. I have to prove. Okay. Let k is equal to a1 divided by a2. Then this implies a1 is equal to k into a2. Sorry, this is b1 is equal to k into b2, and c1 is equal to k into c2. Okay. Now the roots of equation 1. Of course, in the last page also we have taken this as equation 1 and equation 2. Equation 1 are minus b1 plus or minus under root b1 square minus 4a1 c1 divided by 2 into a1. If I am substituting these expressions there, this becomes minus k into b2 plus or minus, this is k square b2 square minus 4 into k into a2, this is k into c2 divided by 2 into k into a2. Now this is minus k into b2 plus or minus, in both these terms under root I can take 1k common, and the left out term is b2 square minus 4 into a2 c2 divided by 2 into k into a2. Now what am I going to get is k, if I take common, this becomes minus b2 plus or minus under root b2 square minus 4a2 c2 divided by, this is 2k into a2. Now this k and this k gets cancelled, so this implies this is minus b1 plus or minus under root b1 square minus 4a1 c1 is equal to, divided by 2 1 is equal to minus b2 plus or minus under root b2 square minus 4a2 c2 divided by 2a2. So this implies, what is the conclusion? The roots of 1 and 2 are identical. So here completes the proof. We have proved both the ways. Okay. Now let me discuss a corollary related to this. The corollary is this one. If alpha comma beta are the roots of ax square plus bx plus c is equal to 0, then alpha beta are the roots of kax square plus kbx plus kc is equal to 0 for all k not equal to 0. What is the relation between these two? These two just differ by a constant. That means each and every term here gets multiplied by k. That means the coefficients are proportional. In the wake of the previous result, the roots of these two quadratic equations are one and the same actually. Now, so far we have seen, given a quadratic equation, how to find out the roots with the help of the formula minus b plus or minus under root b square minus 4ac divided by 2a. Now, now the other way around is, if given roots alpha comma beta, then find quadratic equation. And we have seen this relation already. Ax square plus bx plus c is equal to a into x square plus b by a into x plus c by a, and this can be written as a into x square minus sum of the roots is equal to b by a, and c by a can be written as the product of the roots, that is equal to a into x minus alpha into x minus beta. So this implies ax square plus bx plus c divided by a is equal to x minus alpha into x minus beta. Okay, so this is nothing but x square plus b by a into x plus c by a is equal to x square minus alpha plus beta into x plus alpha beta is equal to 0. Okay, that means now the quadratic equation is going to be this one. Now, as the previous result says, given two roots, I can find out this equation. So with this one equation, from this one equation I can generate many more equations just by multiplying a constant. However, I can make my answer unique by imposing a condition that leading coefficient of the quadratic equation is 1. Okay, so in that case my answer is going to be, this is what precisely this point is. The quadratic equation whose roots are alpha comma beta, for which the coefficient of x square is 1, is x square minus of alpha plus beta into x plus alpha beta is equal to 0. So from now onwards, if alpha comma beta are the roots given to find out a quadratic equation, we are going to find out a monic polynomial. A monic polynomial such that the equation becomes x square minus of alpha plus beta into x plus alpha beta is equal to 0. Now we'll solve the next question. Here is the next question. Form a quadratic equation whose roots are 7 plus or minus 2 root 3. So solve let us find out a quadratic equation whose roots are 7 plus or minus 2 root 3. Previously, we have seen problems wherein, given a quadratic equation, we have seen how to find out the roots of a quadratic equation. Now, roots are given, you have to find out the quadratic equation. Now, in this, given that alpha is equal to, let alpha is equal to 7 plus 2 root 3 and beta is equal to 7 minus 2 root 3. Okay. Now, we know that if alpha comma beta are the roots, then equation whose roots are alpha comma beta is x minus alpha into x minus beta. Here we are taking a monic polynomial actually. Now this x minus alpha into x minus beta is equal to x square minus of alpha plus beta into x plus alpha into beta. Now let us find out what is alpha plus beta, that is 7 plus 2 root 3 plus 7 minus 2 root 3, that is equal to 14, and alpha beta is equal to 7 plus 2 root 3 into 7 minus 2 root 3, that is equal to 7 square minus 2 square into 3, that is 49 minus 2 square is 4, 4 into 3, 12, that is equal to 37. So the equation whose roots are alpha comma beta is x square minus alpha plus beta is 14 into x plus alpha beta is 37 is equal to 0. So the final answer is x square minus 14x plus 37 is equal to 0. This is the final answer. Now similarly we can solve this equation, this problem also. Here is, let us write down the solution. Given alpha is equal to minus 3 plus 5i and beta is equal to minus 3 minus 5i. Now we'll use this following point to find out the quadratic equation. Now for that we need these two quantities, namely alpha plus beta. Alpha plus beta is minus 3 plus 5i minus 3 minus 5i, that is equal to 6, and alpha beta is equal to minus 3 plus 5i into minus 3 minus 5i, that is equal to minus 3 whole square minus 5i whole square, that is equal to 9 minus of minus 25, that is going to be 34. Now the quadratic equation whose roots are the given alpha comma beta is x square minus half alpha plus beta into x plus alpha beta is equal to x square minus alpha plus beta is minus 6 into x plus alpha beta is 34. So this is x square plus 6x plus 34. So therefore the required quadratic equation is x square plus 6x plus 34 is equal to 0. Okay, let us solve some more problems. Okay, here is the question. If alpha comma beta are the roots of the equation x square plus px plus q is equal to 0, form a quadratic equation whose roots are alpha comma beta. Now here is the solution. Let us find out the solution for this. If alpha comma beta are the roots of x square plus px plus q, then alpha plus beta is equal to minus p and alpha beta is equal to q. In the beginning of our lecture we have reviewed these things. Okay, now what is that you have to find out is you have to find a quadratic equation whose roots are alpha minus beta comma alpha plus beta. Now let us first let alpha dash is equal to alpha minus beta whole square. Let us say, let us find out this quantity. Okay, alpha minus beta whole square, in the last problem we have seen alpha minus beta whole square is equal to alpha plus beta whole square minus 4 into alpha beta. Hope you know this identity. We are using this identity actually. A plus b whole square minus a minus b whole square is equal to 4ab. This relation is well known to us. I am using that relation here. Okay, now so alpha dash is going to be alpha plus beta. Alpha plus beta is what? Minus p whole square minus 4 into alpha beta is q. So this implies alpha dash is going to be p square minus 4q. Okay, now let us find out. Let beta is equal to, let beta dash is equal to alpha plus beta whole square. Anyway, this is a known quantity. This is going to be minus p whole square. Now we have to find out quadratic equation whose roots are alpha minus beta whole square comma alpha plus beta whole square. That means we have to find out quadratic equation whose roots are alpha dash comma beta dash. So the required quadratic equation is what? X square minus of alpha dash plus beta dash into x plus alpha dash beta dash is equal to 0. Now in order to find out this quantity we need to find out these two, namely alpha dash plus beta dash. What is alpha dash plus beta dash? Alpha dash is p square minus 4q plus beta dash is going to be p square, that is going to be 2p square minus 4q. Next one is alpha dash into beta dash is p square minus 4q into p square, that is equal to p to the power 4 minus 4 into p square into q. Okay, so the required quadratic equation is x square minus alpha dash plus beta dash is p square, so it is 2p square minus 4q into x plus alpha dash beta dash is p square into p square minus 4q is equal to 0. So the final answer is the required equation is x square minus 2p square minus 4q into x plus e to the power 4 minus 4 into p square q is equal to 0. This is the final answer actually. This is the required quadratic equation that we want. Let us solve the next problem. Here is our next problem. Prove that the roots of x minus a into x minus b is equal to h square are always real where a comma b comma h are real. This is actually the question on the discriminant. Now let us solve this problem. Here is the solution. So here is the quadratic equation. The given quadratic equation is the given quadratic equation is x minus a into x minus b is equal to h square. Now that can be written as x square minus of a plus b into x plus ab is equal to h square. Let us put it in the form of an equation. It is x square minus of a plus b into x plus ab minus h square is equal to 0. We call it as equation 1. Now what is that we have to prove? Prove that roots of this quadratic equation are always real. So when do we say that the roots of a equation are real? Provided the discriminant is greater than or equal to 0. Because only in these two cases, either delta is equal to 0 or delta is greater than 0, then only the roots are real and real. In the first case, it is real and equal. In the second case, it is real and distinctive. But in any way, these two cases can be put together as discriminant delta is greater than 0. Okay, now if delta is less than 0, it is going to be, the roots are going to be complex numbers. Now let us find out discriminant of the equation 1. So discriminant delta is equal to b square minus 4ac, that is minus of a plus b whole square minus 4 into a, that is 1, into c here is ab minus h square. So this is going to be a plus b whole square minus 4ab plus 4 into h square. So this is the discriminant actually. Now if I rewrite this, this is going to be a plus b whole square minus 4ab. Now this part I'll write it separately, plus this is 4h square. Now that is equal to, now this quantity can be written as a minus b whole square, and this I am writing as it is. Now what is the value of delta now? Delta value is going to be, delta value is going to be a minus b whole square plus 4 into h square. This quantity is positive and this quantity is also positive. So this quantity is going to be greater than or equal to 0. So discriminant for equation 1 is greater than or equal to 0. This implies the roots of the given quadratic equation, the given quadratic equation are are real. Hence we have proved the given result. Now we'll solve some more problems based on the quadratic equation. That means here we try to solve this kind of an equation with the help of a quadratic equation. As such, it is not a quadratic equation. Looks like it's not a quadratic equation, but still we can solve this quadratic equation. Still we will be able to solve this equation with the help of a quadratic equation. Let us see how it is. Now let us take a substitution. Let this quantity, that means x to the power 1 by 3 is equal to t, let us say. This implies what? X is equal to dq. Let us keep it aside. Now we are taking x to the power 1 by 3 is equal to t. Now we call this as equation 1. Now substitute this x power 1 by 3 is equal to t in equation 1. Put it in 1. In equation 1 we get, what do we get actually? It is t square plus t minus 2 is equal to 0. Now this seems to be a quadratic equation. This seems to be a quadratic equation. Now let us call it as equation 2 actually. Okay. Now what we will do is, first we will try to solve equation 2 and later on we'll try to solve equation 1 with this, with the help of this substitution. Okay. The roots of equation 2 are what? Minus 1 plus or minus under root b square, that is 1 square, minus 4 into a into minus 2 divided by 2 into 1, that is equal to minus 1 plus or minus under root 1 plus 8 divided by 2 actually. So this is minus 1 plus or minus 3 divided by 2. If you do that, you are going to get these two roots, minus 2 comma 1 actually. Now let us, of course, we have not solved the equation completely, we have solved it partially. That means we have solved the values of t. These are the values of t actually. These are t values actually. But in the question, we are asked to solve for x values actually. So the first case is going to be t is equal to -1. Then in that case, if t is equal to -1, then x is equal to t cube is equal to -1 whole cube. So x value is equal to -1. Now, what is case 2? Now, case 2 is what? This t value is equal to, sorry, actually, this t value is 1. T value is 1. Correspondingly, here also you will get 1. Correspondingly, here also you will get 1. Here you will get 1 actually. Okay. Now, t is equal to -2 here. If t is equal to -2, then x is equal to t cube, that is equal to -2 whole cube, that is equal to -8. So therefore the solutions of the given equation are x is equal to 1 comma -8. Now verification. How do we verify? We can verify whether our answer is correct or not. We substitute these values in the given equation. 1 to the power 2 by 3 plus 1 to the power 1 by 3 minus 2. This is going to be 1 to the power 1 by 3 whole square is 1 plus 1 minus 2, that is equal to 0. Okay, so 1 is a solution actually. Now in order to find out the next one, -8 is a solution or not, we just plug in -8 here plus -8 whole to the power 1 by 3 minus 2 actually. So -8 whole to the power 1 by 3 is -2. This is -2 whole square minus 2 actually. This is -2. So that is 4 minus 4 is equal to 0. So this implies -8 is a root. So the values that we have got is correct actually. So these are our solutions actually. Right. Now let us solve one more equation which can be solved with the help of a quadratic equation. Here is the question. Now let us try to solve this particular equation with the help of a quadratic equation. Now, given equation, I will rewrite 3 to the power 1 minus x minus 10 is equal to 0. Now this can be written as 3 into 3 power x plus 3 into 3 to the power minus x minus 10 is equal to 0 actually. So we are using this property of reals. A to the power m plus n, it is a to the power m into a to the power n actually. Okay, now this can be written as 3 into 3 power x plus 3 divided by 3 power x minus 10 is equal to 0. Now you can guess that we are going to substitute here this 3 power x with some variable. Okay, let t is equal to 3 power x. We call it we call it as equation 1. This we call it as equation 2. Then equation 2 becomes the following: 3 into t plus 3 by t minus 10 is equal to 0. Then this becomes 3t square plus 3 minus 10t divided by t is equal to 0. This implies this is 3t square minus 10t plus 3 is equal to 0. Now we have got this equation in the equation 3. Now let us solve this equation. The roots of equation 3 are minus of minus 10 plus or minus b square. B square is what? It is 10 square minus 4 into 3 into 3 actually, divided by 2 into 3. So that is going to be 10 plus or minus 100 minus 9 into 4 36. So 100 minus 36 divided by 6 actually. So that is 10 plus or minus 8. Square root of 64 is 8 actually. So the roots are 10 plus 8 is 18. 18 by 6 is 3. 10 minus 8, that is 2. 2 by 6 is 1 by 3 actually. So the roots are 3 comma 1 by 3. That means the roots of equation 3 are 3 comma 1 by 3. Now we have to solve for the values of x. Now let us do it case wise. The first case 1, if t value is going to be 3, and the second case is t value is going to be 1 by 3. So if t is equal to 3, then 3 power x is equal to t, that is equal to 3. So this implies x is equal to 1. Now if t is equal to 1 by 3, then 3 power x is equal to t is equal to 1 by 3. So this implies 3 power x is equal to 3 to the power minus 1. This implies x is equal to minus 1. So the solution for the given equation are x is equal to 1 comma minus 1. upon substituting x is equal to 1 in the given equation, it is going to be, so this is just for a verification purpose. This is just for verification to check whether our answer is correct or not. So it is 3 to the power 1 plus 1 plus 3 to the power 1 minus 1 is equal to 3 square plus 3 to the power 0 is equal to 9 plus 1, that is equal to 10. Similarly, if I substitute minus 1 also, I will get the same result. So this solution is correct actually. So let me box my solution. Right. Okay. Let us solve the next equation, which can be reducible to a quadratic equation similar to that of the previous two problems. Now let us solve this question, this equation. Now all types of equation cannot be done here. Only equations of fourth order can be solved here. Of course, if you look at the degree of this equation, the degree of this equation is actually 4. But we have studied in this chapter, we know how to solve degree 2 equations. But we are solving degree 4 equations with the help of quadratic equations. Let us see how. See, one thing you can observe here is the coefficients here will follow certain patterns here. The first one is the first coefficient and the last coefficient, and the second one is second first, you can see, and the second last. So they are also same. The middle one anyway, there is no comparison. Now if the equation is of this form, then only we are able to solve this equation of degree 4 actually. Now let us see how are we going to solve this equation. So the solution here is, here it is 2 into x to the power 4 plus x cube minus 11x square plus x plus 2 is equal to, now what I will do, we call it as equation 1. So 1 I'll divide it with x square. So what do I get actually? So 2 into x to the power 4 plus x cube minus 11x square plus x plus 2 divided by x square is equal to 0. Then this implies what? So 2 into x square plus x minus 11 plus 1 by x plus 2 by x square is equal to 0. Now what is that I am going to do here is, I'll club these two terms basically. I'll club these two terms and I'll club these two terms. I'll club these two terms. Now what is that? What has happened here? So 2, if I take common, this is going to be x square plus 1 by x square plus, this is going to be x plus 1 by x minus 11 is equal to 0. Now what we are going to do here is take the substitution x plus 1 by x is equal to t. Okay. Now this implies upon squaring we get x square plus 1 by x square plus 2 into x into 1 by x is equal to t square. This implies what? X square plus 1 by x square plus 2 is equal to t square. So this implies x square plus 1 by x square is equal to t square minus 2. So this is the advantage. Now we have x plus 1 by x is equal to t, and x square plus 1 by x square is equal to t square minus 2. So maybe we call it as equation 2. This we call it as equation 3. Now put equation 3 in equation 2. Then what do we get is 2 into x square plus 1 by x square is t square minus 2 plus x plus 1 by x value is t actually minus 11 is equal to 0. Then this becomes 2t square minus 4 plus t minus 11 is equal to 0. So that is going to be 2t square plus t minus 15 is equal to 0. Now let us try to solve this equation. This is equation 4. Solve equation 4 actually. So this is going to be, t values are going to be minus 1 plus or minus b square, that is 1 square, minus 4 into a into c divided by 2 into 2, 2 into 2 actually. So this is going to be minus 1 plus or minus under root 15 into 2 is 30, 30 into 4 is 120, so 1 square plus 120 divided by 4 actually. So the t values are going to be minus 1 plus or minus 11 by 4, minus 11 minus 1 minus 12 by 4 is minus 3, minus 1 plus 11 is 10 by 4. Then this is going to be 10 by 4 is going to be 5 by 2 actually. Okay, let us see the values here are case 1. Let us take it case 1. Case 1, the values here are minus 3 comma 5 by 2 actually, so it is minus 1 plus 11. Minus 1 plus 11 is 11 minus 1 is 10, 10 by 4 is 5 by 2. So the first case is going to be The first case is going to be t is equal to 5 by 2. Now we have x plus 1 by x is equal to t, and that value is equal to 5 by 2. Then this implies x square plus 1 divided by x is equal to 5 by 2. This is equal to, it is 2x square plus 2 minus 5x is equal to 0. So this is 2x square minus 5x plus 2 is equal to 0. Now this can be rewritten as plus 2 is equal to 0. Of course we can factorize it like this. So this implies it is 2x minus 1 into x minus 2 is equal to 0. This implies the roots are, so 2x minus 1 is equal to 0 implies x is equal to 1 by 2 under 2. So the roots are 1 by 2 comma 2 actually. Now we have case 2 actually. Case 2, this value is if t is equal to minus 3. So we have x plus 1 by x is equal to t, that is equal to minus 3, implies x square plus 1 by x is equal to minus 3, implies x square plus 1 is equal to minus 3x. So it is going to be x square plus 3x plus 1 is equal to 0. Let us solve this equation, whatever it is, let us call it as equation. The roots are minus 3 plus or minus under root p square plus 3 square minus 4 into a into c is divided by 2 into 1. So therefore the roots are minus 3 plus or minus under root 5 divided by 2 actually. So the roots of given equation are 2 comma 1 by 2 minus 3 plus or minus root 5 divided by